Hi guys, it's Miss Murphy. How are you? I hope you're doing good. Let's take a quick look at how to experimentally determine the specific heat of a metal. It's going to be awesome. It's going to be great. It's going to be so good. It's going to be the best ever. The best ever. Okay. We're just going to do one practice problem. We'll see how that goes. All right, guys. All right. It's basically the same thing. Couple things that you need to realize is that the density, oops, goodness gracious. The density of water is assumed to be 1.0 gram per milliliter. Okay. Keep that in mind when solving any problem. You can assume it to be 1 unless told otherwise. It is temperature dependent. Let's look at our data up here. It says we've got a 12.48 gram sample of a metal. We don't know the identity. We may be able to figure it out from our calculations. Is heated to 99 degrees. So that means its initial temp is 99.0 degrees Celsius. It was put into, so this metal that is hot, it's actually 99.0 degrees Celsius hot, was put into a 50.0 milliliter sample of water. Okay? So we have 50.0 milliliters of water. Okay. This is kind of my data over here, right? So I wanted to add it to my data over there. 25 degrees Celsius. So the initial temp of the water is equal to 25.0 degrees Celsius. And make sure you realize that's a 5, right? The temperature of the water rose to, so the final temperature of the water is equal to, I think it's a 28.1 degrees Celsius. Okay, so this went from 25.0 to 28.1 degrees Celsius. Okay. And assuming no loss of energy to the surroundings, let's go straight to the final question. It says, what is the specific heat of the metal? Right? Those are the steps we would need to take. However, we could omit number 3. So if you get confused, you could take these steps, but you're allowed to omit number 3. If you are confused, you will do step 1, step 2, step 4, and I'm going to do the same thing. Now let's just talk about what's going on. We have a hot piece of metal going into our water, right? So we know that we will gain heat here, right? Here we will gain heat, and over here we will lose heat. But we know that the heat gained will be equal to the heat lost. We know that. And we know that they will both come to the same temperature. Therefore, the final temperature of the water is also the final temperature of the metal. Okay? So we know this. We've talked about it. We need to realize that it applies. It applies right here. The heat lost by the metal equals the heat gained by the water. So in solving this problem, since I need the specific heat of the metal equals question mark, remember the specific heat of water is 4.184 joules per gram degrees Celsius, okay? So what I'm going to do, as number 1 says, is I'm going to calculate the heat gained by the water. And I'm going to be very particular with my labels. I want Q water. Well, that's equal to the mass of the water, the specific heat of the water, and the change in temp of the water. Okay. Let's look up here. Let's see, I have 50 milliliters of water. Oh, right. And I know that 50 milliliters of water, I know the density of water, every 1 milliliter is 1.00 grams. Therefore, I have 50 grams of water. So in my specific heat equation, the heat gained by the water is equal to the fact that I had 50 grams of water. The specific heat is that 4.184 joules is taken for each gram to go up a degree Celsius. And our temperature change went from the final at 28.1 degrees Celsius minus the initial at 25.0 degrees Celsius. So I need to subtract and then multiply all of those. So that's 3.1 when I subtract. So 3.1 times 4.184 times 50 equals 648.52. Q of water equals 648.52. That is joules, because the grams cancels, the Celsius cancels, and I'm left with joules. Recall the next step, that's step 1. The next step, recall that the heat lost by the water, that was actually gained, I'm sorry. The heat gained by the water, right, is equal to the heat lost by the metal, right? The water warmed up because we put the hot metal in it. Well, we see that the water gained 648.52 joules. Therefore, the metal lost 648.52 joules. So I can now say step 4, Q, remember you could skip step 3. The heat of the metal equals the specific, the mass of the metal, the specific heat of the metal, and the change in temp of the metal, right? I know that the heat lost by the metal was 648.52 joules. That's because the water gained that much heat. And the heat gained is equal to the heat lost. I know that my mass of metal, according to my data chart, was 12.48 grams. I am solving for the specific heat of my metal. And the change in temperature of my metal, well, it looks like it went from 28.1 final minus 99 initial. 28.1 final minus 99.0 initial. So I will divide this by the product of this and this, right? So what is 28.1 minus 99? Negative 70.9. Okay, that's that, that's that, that's that. I'm doing this slowly for anyone who is not good at math. I just rewrote everything after I subtracted. Okay, now I'm going to divide this by 12.48 grams, because that will cancel that. And negative 70.9 degrees Celsius. And that'll cancel that. I'm left with C equals, and in my calculator, I'm going to put the negative 648.52, and I'm going to divide it by parentheses 12.48 times negative 70.9, close parentheses, equals, and I get 0.733. That is a joule per gram degrees Celsius. That is the specific heat of the metal. All right. So if you get confused, you can look up here and you could see that the first thing we did was we determined the joules of energy absorbed by the water. We did that by doing Q water equals mass water, specific heat of water, change in temp. And this was all for the water. We then said Q of water, number 2, how much joules did the energy lose? Did the metal lose? Well, it's equal to the negative form of the water, right? We then did Q metal equals MC delta T, and we solved for the specific heat of the metal here. Up here, we solved for Q. And then we plugged that Q into here, but changed the sign and solved for C. And that was our answer. All right. Yay. Stop. Collaborate and listen.